Beat the heat this summer and understand the physics of your AC. We'll explore how refrigeration works and why energy efficiency matters.
When the summer heat peaks, relief comes from a single button and an immediate blast of moving air. We usually treat these machines like fans that generate cold. In reality, the process is far more complex than just pushing chilled air into a room. Misunderstanding the machine leads to expensive mistakes. Consumers buy units that are sized incorrectly for their spaces, or set thermostats to extremes that spike energy bills while leaving bedrooms feeling damp and sticky. Every air conditioner functions as a thermodynamic engine designed to evict heat from your home. Understanding the physics of that eviction is the only way to minimize the cost of staying cool. Think of the refrigeration cycle as a heat kidnapping operation. It captures heat energy indoors and forcibly dumps it outside. This diagram shows the four-part cycle in action. It begins indoors at the evaporator coil. As warm room air blows over the cold refrigerant liquid, the refrigerant absorbs the thermal energy and turns into a low-pressure gas. That warm gas travels to the compressor in the outdoor unit. The compressor violently squeezes the gas, concentrating the thermal energy, until both the pressure and temperature skyrocket. This scorched gas enters the condenser coil. Because the gas is now hotter than the outside summer air, the heat naturally radiates away. As it loses that energy, the refrigerant condenses back into a high-pressure liquid. The cycle concludes at the expansion valve. This component acts as a bottleneck, creating a sudden drop in pressure that freezes the liquid before it returns to the indoor coil to capture more heat. Since cooling is actually heat subtraction, the quality of your AC depends entirely on how efficiently these mechanical parts can move that thermal energy. We measure that moving capacity in tons. As these historical records show, the term has nothing to do with the machine's weight. 1 ton of cooling capacity is the amount of heat required to melt a 2,000-pound block of ice over a 24-hour period. Selecting an undersized AC creates an operational dead end. The machine lacks the capacity to overcome the heat entering the room, so it runs at 100% power indefinitely, burning out the motor without ever reaching the target temperature. An oversized unit is equally problematic. It cools the air so rapidly that it reaches the target temperature and shuts off before it can extract the humidity. This results in a cold, clammy room that feels perpetually sticky. Precise sizing is required because an AC must perform a secondary thermodynamic duty, dehumidification. Human comfort relies on moisture removal just as much as temperature reduction. Once you have the right capacity, the next efficiency hurdle is the compressor drive. This is the divide between fixed-speed systems and modern inverters. This graph illustrates why fixed-speed compressors are inefficient. They operate on binary logic, running at either 0 or 100%. Every time the room warms up, the machine requires these high power spikes to restart the motor. In contrast, inverter technology uses a variable frequency drive. As this second line shows, the compressor ramps up once and then modulates its speed to match the cooling demand. It slows down to a low-power cruise instead of shutting off. Eliminating the violent start-stop cycle prevents mechanical wear and reduces power consumption by 30 to 50%. The Bureau of Energy Efficiency standardizes these technical differences through star ratings and a metric called ISEER. ISEER stands for Indian Seasonal Energy Efficiency Ratio. It is the total heat removed from a space divided by the total electricity consumed over a full season. A higher ratio indicates a more efficient machine. This presents a clear trade-off. A high-efficiency 5-star inverter AC requires a significantly higher upfront price than a standard 3-star non-inverter model. For anyone running an AC 8 or more hours a night, the math favors the efficient choice. A 5-star unit prevents enough electrical waste to recover that price premium through lower utility bills in just 1 to 3 years. Balancing thermodynamics, tonnage, and ICER allows you to select a machine that maintains indoor comfort without ballooning your monthly energy expenses.